Hi everyone, in this video I am going to discuss how to measure the unknown impedance. Unknown impedance can be measured using magic T method or by using slotted line method or by using reflectometer method. So by using any one of these three methods, unknown impedance can be measured, and using magic T, unknown impedance measurement can be seen in other unit. So here we are going to see how the unknown impedance can be measured using slotted line method and reflectometer method. So first we are going to discuss about slotted line method for measuring the unknown impedance. So here these are the setups for measuring the unknown impedance in the slotted line method. So first here what we are going to do is, first we are going to know whether the unknown impedance is a resistive, inductive or capacitive in nature. So from that we can, and then by using the Smith chart we can know the value of unknown impedance. So by using these two setups, first we are going to know whether the impedance is resistive, inductive or capacitive in nature. So first let us see what are the components in setup 1. In setup 1 we are having the source attenuator slotted line, and here on the other end of the slotted line we have connected the unknown load, and on the second end of the slotted line, that is a transmission line, we have connected the crystal detector and the power meter. So here in the first setup we are connecting the unknown load, and we can have the possibility of impedance mismatch. So because of the impedance mismatches, we can have the reflections back towards the transmission line. So suppose a source was generated some signal, and that source generated signal will be transmitted through a slotted line, and then those unknown signals will face a unmatched impedance. So because of the impedance mismatch, we can have the reflections on the transmission line. So incident wave will be combined with the reflected waves. So because of that, standing waves will be formed inside this transmission line, and for these standing waves maximum and minimum values will be detected using crystal detector, and they will be indicated with the help of power meter. So the standing waves will be generated because of impedance mismatch at the second end. So for these standing waves, V max and V minimum values will be measured, and they will be plotted. So here as seen here. Next, in the setup 2, what we are doing the modification is, so in setup 1 we have connected the unknown load, and this unknown load we are replacing with a short circuit in the setup 2. So here the transmission line, when the signal gets transmitted through the transmission line, it will face short end. So because of that short circuit end, waves will be reflected back. So because of those reflected signals, we can have the standing waves formation inside this transmission line. And again for the standing waves, V max and V minimum values will be measured with the help of crystal detector and the power meter. And again these will be plotted. And next, standing waves from setup 1 and setup 2 will be compared. So here by comparing these we are going to know what is the nature of impedance. Suppose if the V minimum value from setup 2 is on the left side of setup 1, then the impedance is inductive in nature, or else it is capacitive in nature. That is, if the V min from the setup 2 is on the right side of V min from setup 1, then impedance we can say it is capacitive in nature. From setup 1 and setup 2 we will measure the standing waves pattern, and we will compare those two standing waves pattern, and by comparing these two standing waves pattern we can know whether the impedance is inductive or capacitive. If the standing wave patterns V min from setup 2 is on left side, then the impedance is inductive. If the V min from the setup 2 is on the right side, then the impedance is capacitive in nature. And if the two V mins from setup 1 and setup 2 coincides, then impedance is resistive in nature. Then by using Smith chart we can know the value of unknown impedance. This is how we can measure the unknown impedance using slotted line technique. Next, we are going to see how to measure the unknown impedance using reflectometer method. So here we are going to use a reflectometer for measuring the unknown impedance value. So for measuring the unknown impedance value, first we need to know the value of reflection coefficient, which will be indicated by the reflectometer. And we are going to measure the reflection coefficient using the characteristics of reflected signal. So by using the incident and reflected signals characteristics, we are going to measure the reflection coefficient, and then from that reflection coefficient impedance value can be measured, and this is a total setup for measuring the reflection coefficient value. So first source generated signal will be transmitted through the attenuator. Through the attenuator, directional coupler will direct the signal to two output ports. So if this is port 1, this will be port 2, and this will be port 4 for the directional coupler. So here this forward directional coupler is directing some part of the signal to the forward detector, and this forward detector will measure the incident signal value and it will direct that to the reflectometer. Next, some part of the signal is getting transmitted through the another directional coupler towards the load, and here we can have the problem of impedance mismatch. So because of impedance mismatches, reflections will be done. So these reflected signals will be directed by the reverse directional coupler to the reverse detector, and this reverse detector will detect the reflected signal value, and that reflected signal amplitude will be forwarded to the reflectometer, and this reflectometer will indicate the value of reflection coefficient by taking the ratio of reflected power and incident power square root. Next, by using this reflection coefficient, unknown impedance will be measured by using the formula Z minus Zg by Z plus Zg, and here Zg is a waveguide impedance which will be generally 50 ohms or 70 ohms, and here from the reflectometer we can know the value of reflection coefficient. By substituting these two values, unknown impedance can be measured. So this is how by using reflectometer unknown impedance can be measured. So that is about impedance measurement. Thank you.